So hello and welcome to Rahi Systems' third webinar in our series of critical infrastructure solutions. My name is Marcus Doran and I am the General Manager for Rahi Systems in Europe. And our webinar today will be focusing on what is our leading in-row cooling technology for server rooms and data centers from our partner Endconnects. I'm happy to introduce today's presenter, Ken Kiernan. Ken is the Director of Strategic Accounts at Rahi Systems and has expertise in data center and telecommunications, specializing in power and cooling products as well as infrastructure components and monitoring solutions. Prior to joining Rahi Systems, Ken spent 15 years involved with critical infrastructure, precision environmental control and power conditioning systems for the telecommunication and IT industry. So we're looking forward to Ken's presentation over the next 20 minutes or so, and we ask our attendees to use the chat box in the meeting for any questions that you may have. We will try to address these after Ken's presentation, and if we don't get the opportunity to come back to those, we will follow on after the call. So thank you again for joining, and now I hand you over to Ken.
Thank you, Marcus, and hello everyone, and welcome to today's webinar. My name is Ken Kiernan, the Director of Strategic Accounts with Rahi Systems. Today I would like to talk with you about data center in-row cooling technologies and how we are addressing today's heat loads. So today, let's go to the agenda. We are going to talk about overall trends in the data center marketplace and typical data center cooling design, specifically around designs and innovation with row-based cooling. And then we'll recap with how we are addressing these critical requirements in the marketplace. And hopefully, if time allows, we will be able to take a few questions from the audience. So let's move along to data center trends. I'd like to talk to you a little bit about data center trends from two important perspectives. One would be design and technology trends, and the other one would be the business market trends. So, on the technical side, on a macro level, we are seeing machines deployed with ever-increasing compute power and ever-decreasing compute footprint. This contributes directly to increasing the power density and the heat density in the data center. This also contributes to increasing, of course, running costs in the data center. So on the business side, we're seeing huge increases in data center volume. Everybody talks about IoT, or Internet of Things, content delivery networks, industrial automation. These are all driving factors and key challenges in how we manage our heat loads. So how do we continue to scale the cloud? How do we continue to scale large data centers, and even on the smaller side, the points of presence and the edge data centers efficiently? How do we keep up with these rapidly growing trends? And how do we build faster? How do we build more efficiently? And more importantly, how do we reduce cost? So on the next slide, we take a look at data center cost and first cost. First cost is always important, but in the life of a data center, it comes down to power and operating cost. So OpEx is always key. There was a Department of Energy study, and that was I was looking at recently in the U.S. alone. Data centers consume about 70 billion kilowatt hours. That's about 2% of the total energy consumption, and the trend continues to go upward and upward every year. So let's look at power consumption in the data center, and where does the power go? So you take a look at this chart. It clearly shows that the IT load, of course, is more than half of the compute power load consumption in the data center. But then you look at the other side of the graph, the pie, is the infrastructure cost. And cooling is the largest portion at 33% of that. It's the biggest chunk of that pie. So the big challenge is, how do we shrink the overall pie? And obviously cooling efficiently and scalably is a big part of that puzzle. So on the next slide, let's spend a few minutes reviewing different types of cooling designs in the data center. You know, all of these designs we're going to speak of have positives and negatives, and then I would submit that they all have merit and good application in the data center market. And I like to say there's no one size fits all in the data center. So first one is, more of a traditional type of cooling. We call it perimeter cooling, widely used in the data center market. We also call it CRACs or CRAWs, computer room air handlers, computer room air conditioners. It can be deployed in an upflow environment with an overhead ducted system. Can be deployed in a downflow raised floor, and as shown here, it's actually downflow front discharge with hot aisle containment. And actually, that's a very efficient design. And just to quickly touch on containment, hot and cold aisle containment, they do contribute greatly to the cooling efficiency by providing proper cooling to the IT load and returning the hottest IT exhaust air back to the cooling units. So, I'd like to look at, obviously the trends, with the IT trends, you have 20 kW per server rack on upward. Containment is always and should always be looked at and applied in all of these types of cooling scenarios. Also, perimeter units are not considered close coupled, obviously. Perimeter units are, they are not close coupled to the IT load, but they're easy to service, so that's definitely one of the pros. Serviceability, and they maintain the load that way. However, in many cases, they tend to take up valuable IT space, or what we call it white space. Once built in and designed in, there's less opportunity to add or change the design without a major retrofit. And there tends to be a higher first cost and a higher construction cost as well when compared to other types of cooling. So on the next slide, custom air handlers, also being very widely used and are typically placed outside, either on the rooftop or next to the data center. In this case, you see one sitting up on the roof, pulling the hot air from the hot aisle. Here's it's using a containment system, dumping the air into the cold aisle. They're again very easy to maintain and service. However, they are built and they're built to move a great deal of air very efficiently as possible. But this also makes them quite large, and they have the similar issues and space constraints and redundancy issues once designed in. They can be designed in modular chunks, which can actually help mitigate the cost of construction. However, they also tend to have higher first costs compared to the other systems. So let's take a look at liquid cooling. Liquid cooling is a hot topic, pardon the pun. It's also a rapidly evolving technology in the marketplace. Arguably, it's one of the most efficient, as it is close coupled. It's about as close coupled as you can get to the IT load. There's many types of liquid cooling. There's dielectric chemical baths, as you see here. There's mineral baths, and servers are designed to be able to drop right into the bath. There's also maybe more traditional type where there's refrigerant or water piped into the server rack itself, more of a cooling to the chip. Many designs that are coming out on the market. The challenge in many cases is obviously the maintenance issues and the serviceability issues of the servers and the cooling system. Also, in many cases, they may be considered not redundant because it's really tough to be able to design it as an N+1 or a 2N design. So there's some challenges there from a redundancy standpoint. But they have a really good electrical efficiency. So there's their operating cost is much lower. However, the first cost would be considered in comparison pretty high. So let's also take a look at rear door cooling. Also a close coupled type, close coupled to the rack and to the IT load. Also considered a very efficient cooling approach, and it brings the the heat exchanger closer to the IT load. Also eliminates hotspots and can efficiently address much higher densities compared to room-based cooling. Also, of course, much easier to service. However, the challenges are around redundancy. There's typically one rear door cooler per rack. So again, hard to design around an N+1 or 2N. Also in large deployments, the first cost can be considered much higher, and you're managing multiple connections. So managing multiple water and refrigerant connections can also present a problem. Let's take a look at, so row-based cooling, that's what we're going to be really focusing on today. Also known as IRC, or in-row cooling. I think it strikes a very nice balance or compromise between close coupled liquid and rear door cooling. It's very much like that. It provides a very efficient type of cooling deployment and an ability to handle those higher density loads. And we'll talk more about that. But as compared to room-based cooling, the IRC has a better ability and probably a better agility to handle the variable density heat loads. Like cracks and craws, also in custom air handlers, one of the advantages is it is a standalone unit. So you can actually, it could even sit, even though it sits in a row or a pod next to the IT loads, it's much easier to manage and service as compared to obviously the liquid cooling and the rear door cooling systems. Also much easier to design with redundancy, which is key. In a row or a pod level, you can design it around an N+1 or a 2N, where with liquid and rear door cooling you cannot. But however, one of the big cons is like liquid and rear door cooling. There can be multiple piping connections above or below, near the IT equipment, which also is a potential for leaks. So let's talk about the Endconnects IRC and how Endconnects is designing to reduce this risk. Let's back up just a little bit on the intro for the Endconnects row-based. Big picture wise, we've been talking about the trends that I've touched on around high power density and also variable density in of IT equipment. Those are key challenges. They create conditions, for traditional data center cooling. That wasn't, traditional data center wasn't really intended for that. It was more room-based. And the result in the cooling system designs are, they tend to be either oversized, or they can be inefficient, or, the controls can be not fine-tuned, a little bit unpredictable. So row-based cooling, such as the Endconnects IRC, has been developed to address these problems. So let's go to the next slide. So the Endconnects IRC, it was designed from the ground up, in partnership with Rahi Systems, to address the trends for the next generation data centers. It's well instrumented with predictive controls. It can handle the high density heat loads and the variable density heat loads. It has a clean design, and it looks like a server rack, and from the front, you just walk right past it. It's fully integrated controls, and it's got a human machine interface, an HMI, with a modern color touchscreen display. It can handle heat loads, up to 100 kW, per system in a comparatively small footprint, which is pretty impressive. So let's go to the next slide. So yeah, it's designed with some best of breed components. The variable speed EC fans, they're actually designed. They're selected in by EBM Pabst, very widely known manufacturer, and easy to source. And then the color touchscreen, the HMI, very easy to use. The heat exchanger, it's a microchannel coil. Interesting enough, it's a V coil on the chill water unit specifically. It's got a much higher capacity, as we talked about. And that blue color you're looking at, that's a hydrophilic coating, which actually captures condensate and moisture, so there's no moisture carryover, which is key. So a couple more components on the next slide here. So yeah, the Belimo valve, that's the control valve on the chill water unit. Very reliable, very available, at many different entering water temperatures. Also selected for the fact that it is, easy to source and replace in the United States and Europe and Asia. That was key for the supportability of the system. The spot, there's actually a spot and a rope leak sensor, and it's standardly provided with all the units, which is also key for any potential leaks. And then on the next slide we show, the power configuration. It's actually a dual power with a built-in auto transfer switch, and that's standard for on all the systems for electrical redundancy. So on the next slide, so a little bit about the DX system, or the refrigerant-based or glycol-based compressorized system. Again, same form factor, exact same form factor as the chill water system. It's got dual compressors, sourced by Copeland, which is a very, very popular brand, very reliable brand. It's got variable capacity, so it can match IT load from all the way from 10% all the way up to 100% load. It's also got the coil is designed around a dual circuit, so it's got dual circuited, which I consider a reliability feature. So for instance, if you lose one compressor, you won't lose the whole system, which is so you can still run the system at, say, like a part load or half load. So yeah, the controls and all of the components are designed with all the certs, ULs, the CE certs for the United States, Europe, and Asia. So you can deploy these pretty much anywhere. Let's go to the next slide. So here's a design comparison of a 50 rack. So we looked at a 50 rack pod at about 6 kW load per server rack. When we did the comparison, comparing it to like a traditional IRC on the marketplace, pretty much all the other systems are 600 millimeter. This one's a little bit wider, but we looked at it. We actually derated the system based on a higher entering water temperature. So we were looking at it at a rating about 60 kW versus the I guess the competitor for the Endconnects brand would be the 30 kW, and it performed very well. And you could design the system even at N+1 at just 6 units to cool the whole 50 rack pod versus 11 units to of the traditional unit. So there you go. If you take a look, if you think about that, there's less mechanical feeds, there's less electrical feeds, and obviously to deploy the system, you can do it in about half the time. So some other components, on the DX system for specifically, it's got a low profile air-cooled condenser. Also, it also comes available in a water glycol with a dry cooler option. So that's also available. So that really kind of goes into the Endconnects IRC, and just kind of to recap the discussion. Let's take it back. We highlighted in the beginning of the presentation the trends in the marketplace and how we are addressing critical requirements in the marketplace. On the technology side, the trends are around higher power densities and higher heat densities. So on the business side, the trends are around the need for more modularity and scalability, and also the need for quicker deployments. this, it's a fast-paced market, so speed to market is paramount. So, the Endconnects, has developed a cooling product that addresses these technologies and business requirements. And the IRC can also be easily deployed and incorporated into highly scalable and deployable pods. With builds as small as 6 racks all the way up to 50 racks, with peak power densities up of 12 kW and higher. This is one representation of a product that we at Rahi Systems, in partnership with Endconnects, we call the Flex IT Pod, which is ideally suited for everything from retrofits of existing data centers to full built multi-megawatt sites. And finally, with the increased modularity and the improved design, the Endconnects IRC it's easier to deploy, it's easier to install. It's much easier to operate and maintain. So this concludes my presentation. I hope it was helpful and informative, and I'm happy to take any questions. Thank you.
Thanks for that, Ken. That was an insightful view on Endconnex's in-row cooling technology, and also thanks to those who have submitted the questions over the last 20 minutes or so. We're now going to address those questions, and for those that we can get to, as mentioned, we will come back to those questions individually after the webinar. So the first question in, Ken, is what differentiates the in-row cooling from Endconnects over the other players in the industry, such as Schneider and Vertiv?
Marcus, that's a great question, and something that's asked a lot because the IRC, one IRC might look like another IRC. So yeah, Endconnects IRC, Rahi Systems is currently deployed a couple of installations. So I have some personal experience incorporating the IRC into the Flex IT Pod, and we have couple locations in the U.S. and Europe. What I noticed is, probably, I would say 2 key differentiators. One is around cost, and I look at it as cost per kW of IT load. The system what we've seen in the deployments is that it outperforms most IRC manufacturers by actually I would say a conservative margin of 30 to 45%. And this actually goes back to the slide I showed where the Endconnects was compared to the traditional IRC, showing a 50 rack deployment at 6 kW per rack. You can cool the entire load with only 6 units versus 11. So basically, you can cool more without sacrificing valuable IT space. So that's one. Another key differentiator would be the rapid deployability and also the customization of the system. So there were the two projects I was involved when were considered they were considered pretty customizable, with that 6 kW. I mean, it was actually 12 kW per cab. One project was in the U.S., the other one was in Europe, and the IRC and the pod were designed, and from design to deployment, it only took about 4 months. And with comparison to other manufacturers that I'm aware of, that was going to take 2 to 3 times. We were looking at maybe 18 months to get the same deployment for a similar project. So hopefully that answers the question.
And question number 2, you've mentioned that the IRC, or the in-row cooling unit, is leading the way in being the most efficient in-row cooling per kilowatt. Can you expand further?
So yeah, the Endconnects IRC has definitely taken a leadership position in the IRC market for sure, with between a 75 and 100 kW capacity per system. It's definitely on the leading edge, and that all goes back to the base design, the components that were selected for the chill water and the DX are the most efficient on the market. So the guts of the unit are best of breed. And then you would say the secret sauce is probably in the control system. So the intelligent controls and how the system runs from an efficiency standpoint is leading the way in the marketplace. Yeah, and it probably contributes back. You take a look at the studies that were done on the two builds that we were involved in earlier in the presentation. We talked about the comparison based on the traditional approach. You can see how the unit's doing more with less, more cooling with less.
Question number 3 for you, Ken, is the IRC unit modular? Can you talk further about how it could grow as your IT load grows?
So yeah, the modularity. So yeah, the IRC, I mean, the fundamental component of the IRC is to be modular and to incorporate into a pod design or a row-based design that you can actually grow over time. So when you compare it to a traditional data center build, where you have to design the whole cooling plant or the entire chill water plant, for instance, around the end state. If you're looking at a multi-megawatt site, you have to contribute that first cost all at once. Where when you look at the pod design, you can build it in much smaller chunks, much more manageable. So this actually is very popular in the co-location world, and even in the enterprise data center world, and even in any data center retrofits. So of existing data centers where you can go in and start small with say a 6-rack pod with 2 in-row coolers, and grow it out all the way to a 50-rack pod with 6 in-row coolers. So that can all be pre-engineered and pre-designed to be modular. So again, it mitigates that first cost, that CapEx, which no one wants to spend, and then at the end state you have a much more efficient operating cost.
And question number 4 for you, Ken, is can the in-row cooling unit be managed by BMS or DCIM tools?
Yes, great question. Yes, absolutely. The Endconnects IRC control system is designed to interface with virtually any BMS or network management system or DCIM system. And can utilize multiple industry standard protocols. Virtually all the status points, alarm points, and control points can be seen. That can be seen from the colored HMI touchscreen, or can be fed to a BMS or a DSIM system. So linking to external controls is absolutely not an issue.
Great, thanks for that, Ken. So that brings us to the end of our webinar on in-row cooling from Endconnects. I'd like to thank Ken for his presentation and also to the attendees for spending the last 30 minutes with us. We hope you found the session informative. For more information on the in-row cooling unit, we'd like to invite you to our website. That's www.rahisystems.com, and you can find out more information on the Endconnects in-row cooling technologies. That leaves me with also an open invite to our next webinar, which is taking place on April the 18th in conjunction with our storage partner, Rahi Systems. So again,